The moon has been a source of wonder and inspiration for humanity for millennia. From the earliest days of civilization to the modern age of space exploration, the moon has held a special place in our collective imagination. Its silvery glow, constant presence in the night sky, and its cycles have influenced everything from calendars to stories, from art to scientific discoveries. For centuries, the moon was a symbol of mystery, beauty, and divine power. But the moon is much more than just an object in the sky. It has played an essential role in the development of life on Earth. Without the moon, our planet's physical characteristics, such as its tilt and rotation, would be vastly different, affecting everything from the length of our days to the seasons. The moon's gravitational pull has been crucial in stabilizing Earth's climate, ensuring conditions conducive to life as we know it. In this way, the moon is not merely a passive observer of Earth but an active player in the planet's environmental and physical processes. Why has the moon fascinated humanity for so long? Perhaps it's because it is so close, yet so far away, a celestial body that we can see with our own eyes, but one that we could never quite touch. Its cycles, from waxing to waning, have influenced timekeeping and agriculture. Its appearance, whether full or crescent, has inspired myths, art, and poetry. The moon is a constant companion, yet it is one that remains elusive, making it a powerful symbol for mystery and aspiration. Throughout history, the moon has had a profound influence on human culture. Ancient civilizations across the globe linked the moon to various gods and deities, incorporating it into their spiritual practices, religious rituals, and legends. In ancient Egypt, for instance, the moon was often associated with the god Khonsu, a deity of time and healing. In Greek mythology, the moon was personified by the goddess Selene, who drove a chariot across the night sky. Similarly, in Chinese culture, the moon is home to the beautiful Chang'e and her companion, the Jade rabbit. These myths not only shaped the cultural landscapes of their respective civilizations but also left a lasting imprint on art, literature, and philosophy. In more recent centuries, the moon has been the subject of intense scientific study and exploration. Early astronomers such as Galileo Galilei were among the first to point telescopes at the moon, revealing its craters and mountains, challenging the long-standing belief in a perfect, unchanging celestial sphere. Later, the development of modern physics and space exploration would bring humanity even closer to the moon, culminating in the landmark Apollo missions in the 1960s and 1970s. In this era of space exploration, the moon has ceased to be just an object of myth and has become a critical focal point for scientific research, as well as for humanity's aspirations to extend its reach beyond Earth. In this discussion, we will explore the many ways in which the moon has shaped our world, both physically and culturally. From its formation billions of years ago to its central role in human exploration and imagination, we will delve into how the moon has influenced everything from ancient mythologies to modern space missions. We will examine the scientific theories behind its creation and how it continues to impact Earth's environment. We will also look at the moon's enduring presence in art, literature, and culture, and how it has inspired some of humanity's greatest works of imagination. Finally, we will look to the future, exploring how upcoming space missions and scientific advancements may transform our relationship with the moon in the years to come. In this journey through time, science, and culture, we hope to gain a deeper understanding of our relationship with the moon and why this small but mighty celestial body continues to capture our imaginations and spark our curiosity. The formation of the moon. The moon, Earth's closest celestial neighbor, has fascinated scientists for centuries, not only because of its beauty and symbolism but also because of its mysterious origin. While ancient civilizations created myths and legends about the moon's birth, modern science has provided several theories on how this fascinating object came into existence. Over time, researchers have developed hypotheses to explain the moon's formation, focusing on its composition, its relationship with Earth, and its physical characteristics. Today, the most widely accepted theory is the giant impact hypothesis, but there are also alternative explanations that continue to be discussed and debated by scientists. The giant impact hypothesis, Theia collision theory. The most widely accepted theory of the moon's formation is the giant impact hypothesis, also known as the Theia collision theory. According to this theory, the moon was formed as a result of a colossal collision between the early Earth and a Mars-sized body, which scientists have named Theia. This event is believed to have occurred about 4.5 billion years ago, during a period known as the Late Heavy Bombardment, when the inner solar system was still a chaotic and violent place. The collision between Earth and Theia would have been incredibly energetic, sending vast amounts of debris into orbit around the Earth. Over time, this debris began to coalesce under the influence of gravity, eventually forming the moon. The impact itself would have been so powerful that it not only created the moon but also caused significant changes to both Earth and the newly formed satellite. This theory is supported by several lines of evidence. First, the composition of the moon is strikingly similar to that of Earth's outer layers, particularly the mantle. This suggests that the moon was formed from material that was once part of the Earth. Second, the moon's relatively small iron core, compared to Earth's, is consistent with the idea that the moon was formed from the outer layers of both Earth and Theia. The giant impact hypothesis also explains the moon's unusual orbital characteristics, including its tilted axis and its synchronous rotation, the fact that the same side of the moon always faces Earth. Another important piece of evidence supporting the giant impact hypothesis comes from the isotopic composition of lunar rocks, which were brought back to Earth during the Apollo missions. These rocks are remarkably similar to Earth's rocks, further strengthening the idea that the moon formed from material that came from Earth. This similarity suggests that Earth and Theia were made of the same types of material, leading to the formation of a moon that is closely related to Earth in terms of chemical makeup. While the giant impact hypothesis is the leading theory, there are still many unanswered questions about the specifics of this collision, such as the exact size and composition of Theia, as well as the precise mechanics of how the moon formed from the debris. Nonetheless, this theory remains the most widely supported explanation among scientists today. Alternative theories. While the giant impact hypothesis is the dominant explanation for the moon's formation, there are other theories that have been proposed over the years. These alternative theories provide different perspectives on how the moon could have come into existence, though none have been as widely accepted or as well supported by evidence. Fission theory. One of the earliest theories proposed to explain the formation of the moon is the fission theory, which suggests that the moon was once part of Earth. According to this hypothesis, the moon was formed when a rapidly rotating early Earth was spinning so fast that a portion of its material was ejected into space. This material, which would eventually form the moon, is thought to have been thrown off due to centrifugal forces. This theory was first proposed by George Darwin, the son of Charles Darwin, in the late 19th century. While it was an interesting idea at the time, the fission theory has been largely dismissed by modern scientists. One of the key problems with the theory is that it would require Earth to have been rotating at an impossibly high speed for the material to be ejected. Additionally, the composition of the moon does not align perfectly with that of Earth's crust, which makes it unlikely that the moon came from Earth's material alone. Despite its flaws, the fission theory remains an interesting part of the history of lunar formation theories, especially in its early exploration of the dynamics of rotational forces and the role of Earth's gravity. Capture theory. Another alternative theory is the capture theory, which suggests that the moon was originally formed elsewhere in the solar system and was later captured by Earth's gravity. According to this hypothesis, the moon would have been a wandering object, perhaps a rogue planetesimal or an asteroid, that was drawn into Earth's orbit by gravitational forces. While this theory is intriguing, it also faces significant challenges. For one, it would be extremely difficult for an object the size of the moon to be captured by Earth's gravity without some sort of external force, such as a nearby planet, to help slow it down and bring it into orbit. Additionally, the capture theory does not explain the similarities in composition between the Earth and the moon, as the moon would likely have a different chemical makeup if it had been formed in a different part of the solar system. Although the capture theory is not widely supported today, It remains a part of the broader conversation on the moon's origins, particularly in discussions about the dynamics of celestial bodies in the early solar system. Accretion theory. The accretion theory is another alternative explanation that suggests the moon formed at the same time as Earth, from the same protoplanetary disk of gas and dust that surrounded the early sun. According to this theory, the moon and Earth both coalesced from this disk, with the moon forming as a smaller body in orbit around Earth. Over time, the moon would have been slowly accreted from smaller particles of dust and rock, much like the way planets form in the early stages of a solar system's development. While this theory offers an explanation for the moon's close relationship with Earth, it faces a major challenge in explaining the moon's composition. The accretion theory suggests that the moon should have a composition that is much more similar to Earth's, particularly in terms of its iron content, which does not align with what we observe. The moon has a smaller iron core than Earth, which is more consistent with the giant impact hypothesis rather than the accretion theory. The formation of the moon is a subject that continues to inspire debate and research among scientists. The giant impact hypothesis remains the most widely accepted explanation, largely due to the strong evidence it has garnered from the study of lunar rocks, the moon's orbital characteristics, and the dynamics of the Earth-Moon system. However, alternative theories like fission, capture, and accretion remind us that the mysteries of our solar system are far from solved. As technology advances and new discoveries are made, our understanding of how the moon came to be may continue to evolve. Nevertheless, the story of the moon's formation is one of the most fascinating in planetary science, shedding light not only on the history of our moon but also on the early history of the Earth and the solar system as a whole. How the moon shaped Earth's development. The moon is not just a passive satellite orbiting Earth, it has played a critical role in shaping our planet's development. From stabilizing our climate to influencing the length of our days, the moon has had profound effects on Earth's environment and physical characteristics. This section will explore the ways in which the moon's gravitational pull has shaped Earth's development, focusing on its impact on tides, climate stabilization, and the dynamics of Earth's rotation and axial tilt. Tides and early climate stabilization. One of the most noticeable effects the moon has on Earth is the creation of tides. The gravitational pull of the moon on Earth's oceans is responsible for the regular rise and fall of sea levels, an event known as tidal motion. As the moon orbits Earth, its gravitational force exerts a pull on the planet's water bodies, causing a bulge to form on the side of the Earth that faces the moon. This results in a high tide. On the opposite side of Earth, another bulge is formed due to the centrifugal forces caused by Earth's rotation, leading to a second high tide. Between these high tides, low tides occur when the water levels are at their lowest. Tides have played an essential role in shaping the Earth's ecosystems. They regulate the movement of ocean waters, influencing the distribution of nutrients, the behavior of marine life, and the formation of coastal habitats. The moon's gravitational pull has not only created these rhythmic tidal movements but also provided a mechanism for the ocean's circulation. This circulation is crucial for the transport of heat and moisture, helping to stabilize the planet's climate and promote the development of diverse ecosystems. In Earth's early history, the moon's influence on tides was likely even more pronounced, contributing to the stabilization of the planet's climate. The early Earth had a much more volatile climate, with significant fluctuations in temperature and weather patterns. The moon's tidal effects helped mitigate these extremes by stabilizing the ocean currents and atmospheric conditions. This stabilization was crucial for the development of life on Earth, as it created more moderate conditions conducive to the emergence of complex organisms. The relationship between the moon and Earth's tides also has implications for the planet's axial tilt and the stability of its seasons. The combination of tidal forces and Earth's rotation contributed to the overall balance of forces that kept Earth's climate stable over geological timescales. Effects on Earth's rotation and axial tilt. The moon has had a significant influence on Earth's rotation and axial tilt, shaping the length of our days and the consistency of our seasons. When Earth was young, it spun much faster than it does today. Early in its history, Earth's day may have been only around 6 hours long, a far cry from the 24-hour day we experience today. This rapid rotation was likely due to the dynamics of Earth's formation, but the moon played a key role in slowing this rotation over time. The gravitational interaction between the Earth and the moon causes tidal friction, which gradually slows down Earth's rotation. This process has been ongoing for billions of years, and it is estimated that Earth's day has lengthened by about 1.7 milliseconds per century. While this may seem like a small change, it has added up over time, lengthening Earth's day from just a few hours to the 24-hour period we experience today. This slowing of Earth's rotation has profound effects on life on Earth. For one, the gradual increase in the length of the day has influenced the biological rhythms of life on our planet. Many organisms, including humans, have evolved in sync with Earth's 24-hour cycle, known as the circadian rhythm. The moon, by slowing Earth's rotation, has effectively set the tempo for life on Earth, shaping the daily cycles of activity and rest for countless species. The moon's influence extends beyond the length of the day to Earth's axial tilt. Earth's axial tilt, or the angle at which our planet is tilted relative to the plane of its orbit around the sun, is responsible for the changing seasons. Without the tilt, there would be no variation in temperature throughout the year, and the Earth would experience an eternal spring. The moon has played a stabilizing role in maintaining Earth's axial tilt. Earth's axial tilt is currently about 23.5 degrees, but this angle is not fixed. Over long periods of time, Earth's tilt can vary due to gravitational interactions with other celestial bodies, a phenomenon known as axial precession. Without the moon, these variations in tilt could be much more pronounced, leading to extreme changes in the Earth's climate. The moon's gravitational pull helps stabilize Earth's axial tilt by acting as a counterbalance. This stabilization is important because it ensures that the tilt remains within a relatively narrow range, preventing extreme shifts that could drastically alter the planet's climate. As a result, the moon has played a critical role in maintaining Earth's relatively mild and predictable seasons. This stability has allowed life to flourish and evolve in ways that might not have been possible if the Earth's axial tilt were constantly shifting. The moon's role in Earth's long-term evolution. The gravitational forces exerted by the moon have not only shaped Earth's physical features but have also played a key role in the long-term evolution of the planet. By influencing the length of the day, stabilizing Earth's climate, and maintaining the consistency of the seasons, the moon has helped create the stable environmental conditions necessary for life to thrive. In addition to the moon's effects on Earth's rotation and climate, its gravitational pull has also influenced the movement of tectonic plates. The shifting of Earth's continents and the activity of volcanoes and earthquakes have been affected, at least in part, by the moon's tidal forces. While the moon is not the sole driver of tectonic activity, its presence has likely played a role in shaping the Earth's geological history. The moon's influence on Earth's development is not a static phenomenon. It has been ongoing for billions of years and will continue to shape the planet's future. As the moon slowly drifts away from Earth, at a rate of about 3.8 centimeters per year, its gravitational influence will weaken and the effects on Earth's rotation and axial tilt will diminish. In the distant future, Earth's day may be longer and the seasons may become more erratic. But for now, the moon remains an essential factor in Earth's stability, influencing everything from the length of our days to the behavior of ocean currents, and it will continue to do so for the foreseeable future. The moon in mythology and ancient cultures. Throughout human history, the moon has held a significant place in the mythology and belief systems of many civilizations. Its influence was felt across cultures, shaping stories, religious rituals, and cultural practices. Ancient societies often viewed the moon as a powerful force, with its cycles and phases having symbolic meanings connected to time, fertility, and the natural world. As a constant and observable presence in the night sky, the moon became not only an object of fascination but also a central figure in the mythology of early civilizations. In this section, we will explore how different ancient cultures viewed the moon, focusing on the Mesopotamian and Sumerian beliefs, as well as Egyptian mythology. Mesopotamian and Sumerian beliefs. Sin, the moon god. In ancient Mesopotamia, which includes the cultures of Sumer, Akkad, Babylonia, and Assyria, the moon was associated with powerful deities who were often linked to both the heavens and the earth. One of the most significant lunar gods in Mesopotamian mythology was Sin, also known as Nana in Sumerian mythology. Sin was the god of the moon, and he played a central role in the religious practices of the Mesopotamians. Sin was believed to be the son of Enlil, the god of air and storms, and Ninlil, the goddess of the atmosphere. He was often depicted as a bearded figure, seated on a throne and holding a crescent-shaped disc, symbolizing the waxing and waning phases of the moon. In Mesopotamian mythology, Sin was seen as the ruler of time, overseeing the passage of months and seasons, and his cycles were closely linked to the measurement of time. The influence of Sin extended beyond the heavens. The Mesopotamians believed that Sin's presence on Earth was felt in the form of the lunar calendar, which governed agricultural cycles and religious rituals. The moon's phases were crucial for determining the appropriate times for planting, harvesting, and conducting religious ceremonies. The prominence of Sin in the daily lives of the people is reflected in the fact that several cities in ancient Mesopotamia, such as Uar and Haran, were dedicated to the worship of the moon god. The moon was not just a symbol of time and agriculture, however. In Mesopotamian mythology, Sin also had connections to wisdom and prophecy. He was considered a wise deity who guided rulers and priests, offering them insight through dreams and omens. The priests of Sin would interpret lunar events and use them to forecast the future, often influencing decisions of state and governance. Sin's temple in Uar, known as the Edamananki, was a major center of worship, and it was from this temple that many of the religious and cultural practices involving the moon were initiated. In addition to his role as a god of wisdom and prophecy, Sin was also connected to the concept of justice. As a judge of both human and divine actions, Sin was seen as a protector of order in the universe. His influence extended beyond the moon itself, with Sin's laws governing the moral and social behavior of the people. This connection between the moon and justice can be seen in the famous Code of Hammurabi, which, while primarily attributed to the sun god Shamash, also invoked Sin's influence in its creation. Egyptian mythology, Khonsu, the moon god. In ancient Egypt, the moon also played an important role in religious and cultural life, with Khonsu being one of the most prominent lunar deities. Khonsu was part of the Theban triad, a group of 3 deities that included the great god Ammonius and his consort Mut. Khonsu, the moon god, was depicted as a youthful figure, often shown as a young man with side locks of hair, wearing a side lock of youth and a lunar disc above his head, representing the phases of the moon. Khonsu was closely associated with time and healing in Egyptian mythology. As the god of the moon, he was believed to control the lunar cycles, which played an important role in the Egyptian calendar. The Egyptians used a lunar calendar for their festivals and ceremonies, and Khonsu was considered to be the protector of the months and the cycles of the moon. He was also seen as a healer, associated with the power of regeneration and rejuvenation. His ability to heal was reflected in his role in Egyptian mythology, where he helped cure the sick and was invoked in prayers for health and restoration. Khonsu's mythological story is deeply connected to the theme of time and transformation. He was said to have the ability to change his form, a characteristic that mirrored the changing phases of the moon. His powers of transformation were central to his role in Egyptian rituals, where he was invoked to bring balance and harmony to the natural world. The Egyptians believed that Khonsu's movements through the night sky were a source of divine power, and his waxing and waning phases symbolized the cycles of life, death, and rebirth. Khonsu's association with the moon also connected him to the concept of the Duat, or the Egyptian underworld. As the moon god, Khonsu was believed to have a special connection to the journey of the soul through the night. During the night, Khonsu would accompany the sun god Ra on his journey through the underworld, aiding in the protection of the sun during its nightly descent. This journey was crucial for the daily resurrection of Ra and the continuation of life on Earth. In this way, Khonsu was not only a god of the moon but also a protector of life and an important part of the cosmic order. The moon's symbolic role in ancient Egyptian culture. The moon in ancient Egypt was not just a deity to be worshipped, it also carried powerful symbolic meanings. The Egyptians associated the moon with Ma'at, the concept of balance, order, and justice, which was central to their understanding of the universe. The cycles of the moon represented the natural rhythm of life and death, as well as the balance between the celestial and earthly realms. The moon's influence in Egyptian culture extended beyond religious practices. The lunar phases were critical for determining the timing of the sacred festivals that were held throughout the year. These festivals were tied to the agricultural cycles, which were themselves linked to the flooding of the Nile River. By observing the moon cycles, Egyptians were able to predict the best times for planting and harvesting crops, ensuring the survival of their civilization. Khonsu's role as a protector of time and the cycles of life was mirrored in his association with the lunar calendar. The Egyptians used the moon's phases to divide the year into months, and Khonsu's cycles were reflected in the daily rituals and prayers that maintained the cosmic balance. These rituals were vital not only for ensuring agricultural prosperity but also for ensuring the stability and continuation of Egyptian society. The moon in Greek, Roman, and Chinese mythology, rituals, and symbolism. The moon has had a profound influence on the mythologies of various ancient cultures, continuing to shape religious practices, literature, and art for centuries. In this section, we will explore the role of the moon in Greek and Roman mythology, where it was personified by deities like Selene, Artemis, and Luna, and in Chinese mythology, where the moon is central to stories about Chang'e and the Jade rabbit. We will also look at the moon's symbolic importance in rituals, calendars, and astrology, as well as its presence in literature, poetry, and religious texts. Greek and Roman mythology, Selene, Artemis, and Luna. In Greek mythology, the moon was personified by two goddesses, Selene and Artemis. These figures were both linked to the moon, but in different ways, representing distinct aspects of lunar influence. Selene was the primordial Titan goddess of the moon. She was often depicted as a beautiful woman driving a chariot across the night sky, her path illuminated by the light of the full moon. Selene's role as the moon goddess was central to her mythological narrative. She was believed to bring the light of the moon to the world each night, controlling the lunar cycles. Selene's association with the full moon made her a symbol of beauty, mystery, and tranquility, but she was also linked to the concept of time, as the moon's phases marked the passage of the months. One of the most famous myths involving Selene is her love affair with the mortal Endymion, a handsome shepherd. In the myth, Selene descends to Earth each night to visit Endymion, who is said to be in an eternal sleep granted by Zeus, allowing him to remain forever young and beautiful. Their union symbolizes the eternal, cyclical nature of the moon, appearing nightly but always changing, always in motion. Artemis, on the other hand, was the Greek goddess of the hunt, wilderness, and wild animals, but she was also closely connected with the moon. Artemis was often depicted as a young woman carrying a bow and arrows, symbolizing her power and independence. As the goddess of the moon, Artemis was associated with the new and waxing moon. She was seen as the protector of women and children, particularly during childbirth, and was often called upon to safeguard women during their most vulnerable moments. In her connection to the moon, Artemis represents the moon in its waxing phases, bringing light and growth, as opposed to the full, older Selene. In Roman mythology, the moon was personified as Luna, the counterpart to the Greek Selene. Like Selene, Luna was depicted as a radiant figure driving her chariot across the night sky. However, Luna's role in Roman culture was more closely associated with fertility and the feminine aspects of life. Luna was worshipped in various rituals that celebrated the cycles of the moon, and she was often invoked in rituals connected to women's health and fertility. The connection between Luna and Selene is often blurred in ancient sources, but Luna's importance in Roman culture was primarily as a goddess who symbolized both the physical and symbolic light of the moon. The Romans celebrated her in various festivals, and her image was often used in art and literature to symbolize the mysterious and life-giving qualities of the night. Chinese mythology, Chang'e and the Jade rabbit. In Chinese mythology, the moon is a rich and deeply symbolic figure, primarily associated with the legendary figure Chang'e and her companion, the Jade rabbit. These myths have been passed down through generations and are closely tied to the Chinese lunar calendar and traditional celebrations like the Mid-Autumn Festival. The myth of Chang'e is one of the most beloved in Chinese folklore. Chang'e, once a mortal woman, became the moon goddess after swallowing an elixir of immortality that was originally meant for her husband, Hou-yi, a renowned archer who had saved the Earth by shooting down 9 of the 10 suns that were scorching the planet. After receiving the elixir, Chang'e ascended to the moon, where she lived in solitude, separated from her husband. In some versions of the myth, she is said to be accompanied by the Jade rabbit, who is often depicted as pounding herbs in a mortar to make the elixir of immortality. The Jade rabbit is a significant figure in Chinese lunar lore. The rabbit is said to live on the moon, and its presence is connected to both the idea of self-sacrifice and the notion of immortality. In many versions of the myth, the Jade rabbit is portrayed as a symbol of humility and dedication, as it sacrifices itself to help Chang'e make the elixir that would eventually separate her from her earthly life. The myth of Chang'e and the Jade rabbit is central to the Mid-Autumn Festival, which is celebrated with mooncakes and the viewing of the moon. This festival, which typically occurs in September or October, marks the moon's fullest and brightest phase, and is a time for families to come together and give thanks for the harvest. The myth, like many lunar myths around the world, symbolizes themes of loss, immortality, and longing, capturing the mystical qualities of the moon. The moon's role in rituals, calendars, and astrology. The moon cycles have had a profound influence on ancient rituals, calendars, and systems of astrology across different cultures. From the establishment of lunar calendars to the observation of celestial events for religious and agricultural purposes, the moon has played a pivotal role in the structuring of time and human activities. In ancient Mesopotamia, the lunar calendar was vital for organizing the year. The Mesopotamians observed the cycles of the moon to track months and seasons, which were essential for agricultural planning and religious ceremonies. The moon's phases were considered to be a sign of divine will, and lunar eclipses were often interpreted as omens of great significance. Similarly, in ancient China, the lunar calendar was used to organize festivals, agricultural activities, and religious observances, all of which were closely tied to the moon cycles. In ancient Egypt, the lunar calendar helped determine the dates for religious rituals and agricultural activities. The Egyptians observed both the lunar and solar cycles, with the moon playing a key role in marking the passage of time. The connection between the moon and the solar year was also important for predicting the annual flooding of the Nile River, which was crucial for agriculture. In Western astrology, the moon is considered one of the most important celestial bodies. It is thought to represent the emotional and intuitive aspects of human nature, with the position of the moon in one's birth chart offering insight into a person's inner world and unconscious mind. The moon's phases, waxing, full, waning, are believed to have significant effects on human behavior, influencing emotions, decisions, and relationships. Symbolism of the moon in literature, poetry, and religious texts. Throughout history, the moon has been a powerful symbol in literature, poetry, and religious texts. Its phases and cycles have often been used to represent the passage of time, cycles of life and death, and the deep mysteries of existence. In literature, the moon is often a symbol of beauty, longing, and unattainable desires. Poets have long drawn upon the moon's ethereal qualities to express the complexities of human emotions. One of the most famous examples is the Chinese poet Li Bai, who frequently wrote about the moon as a symbol of separation and longing, particularly in his poem, Quiet Night Thought, in which the moon's light reminds him of his distant homeland. In religious texts, the moon often serves as a symbol of divine order and a marker of sacred time. In Christianity, for example, the moon is sometimes used as a metaphor for Christ's relationship with the Church. The full moon can symbolize the perfection of divine wisdom, while the waxing and waning of the moon are seen as representations of life's transient nature. Similarly, in Hinduism, the moon is associated with the god Chandra, and its changing phases are connected to the rhythm of life and the universe. In Greek and Roman poetry, the moon is often linked with love, beauty, and transformation. The moon is portrayed as a symbol of the eternal and the fleeting, a divine force that reflects the human experience of longing, loss, and renewal. The moon and science, early observations. The moon, which has long been a source of myth and wonder, became an object of intense scientific inquiry as humans developed more sophisticated methods of observation. With the invention of telescopes and the advancement of astronomical theories, the moon began to reveal more about the nature of the universe and our place in it. Early astronomers and thinkers made significant contributions to our understanding of the moon's features and its relationship with Earth. From Ptolemy's geocentric model to Galileo's first telescopic observations and the groundbreaking work of Isaac Newton on gravity, each step in the history of lunar science marked a major shift in our understanding of the cosmos. In this section, we will explore the contributions of key early astronomers, their theories, and the challenges they faced, particularly the conflict with the Church over the heliocentric model, as well as how the discoveries made during the scientific revolution paved the way for modern astronomy. Early astronomers and their theories. The earliest scientific models of the universe were developed in the ancient world, long before telescopes and modern instruments. These models were primarily based on philosophical and observational reasoning rather than direct empirical evidence. Ptolemy's geocentric model. One of the most influential figures in early astronomy was the Greek-Egyptian astronomer Claudius Ptolemy, who lived in the 2nd century CE. Ptolemy's work, the Almagest, became the authoritative text on astronomy in the Western world for over 1,400 years. In it, he proposed the geocentric model of the universe, which placed the Earth at the center of the cosmos. According to this model, the Sun, the Moon, the planets, and the stars all revolved around Earth in complex, circular orbits. Ptolemy's geocentric model was based on the idea that the Earth was stationary and that all celestial bodies, including the Moon, moved in perfect circular orbits around it. While this model was able to explain many observable phenomena, such as the rising and setting of celestial bodies, it could not accurately account for the observed movements of planets, especially their retrograde motion, where planets appear to move backward in the sky. Despite its flaws, the geocentric model dominated Western thought for centuries and was accepted by both ancient and medieval scholars. It was also integrated into the Christian worldview, as the Earth's central position was seen as evidence of humanity's special place in the divine order. Copernicus and the heliocentric revolution. The geocentric model of the universe remained largely unchallenged until the 16th century, when Nicholas Copernicus, a Polish astronomer, proposed a radically different theory. In his work De Revolutionibus Orbium Coelestium on the revolutions of the celestial spheres, published in 1543, Copernicus introduced the heliocentric model, which placed the Sun at the center of the universe and the Earth, and by extension, the Moon orbiting around it. Copernicus' heliocentric theory was revolutionary because it challenged centuries of accepted belief and introduced a new way of thinking about the cosmos. According to Copernicus, the Moon orbited Earth, but Earth itself, along with the other planets, revolved around the Sun. This model simplified the movements of the planets and explained their retrograde motion more naturally, but it was still not entirely accurate because Copernicus believed the planets moved in perfect circles, a notion later refined by Kepler. Despite its elegance, Copernicus' heliocentric model faced significant resistance. Not only did it contradict centuries of religious and philosophical thought, but it also lacked sufficient observational evidence to be widely accepted. Many astronomers at the time rejected the heliocentric model, preferring the traditional geocentric view, which had been long established by Ptolemy and supported by the Church. Galileo's first telescopic observations. In the early 17th century, the invention of the telescope provided astronomers with a new tool to observe the heavens in greater detail than ever before. The Italian scientist Galileo Galilei was one of the first to use a telescope for astronomical observations, and his discoveries would dramatically alter our understanding of the Moon and the cosmos. In 1609, Galileo began using his telescope to study the Moon, and he made several groundbreaking observations. He discovered that the Moon's surface was not smooth as had been previously believed, but was instead covered with mountains, valleys, and craters. These observations shattered the Aristotelian idea that the heavens were perfect and unchanging. Galileo's findings, which included detailed sketches of the Moon's surface, revealed a much more dynamic and imperfect universe than previously imagined. Galileo also discovered the 4 largest moons of Jupiter, now known as the Galilean moons: Io, Europa, Ganymede, and Callisto. These moons provided further evidence for the heliocentric model, as they showed that not all celestial bodies orbited the Earth. Galileo's work laid the foundation for the acceptance of the heliocentric theory, but it also led to a conflict with the Catholic Church. Conflict with the Church over heliocentrism. Galileo's support for the heliocentric model of the universe brought him into direct conflict with the Roman Catholic Church. By the early 17th century, the Catholic Church had adopted the geocentric model, largely due to its compatibility with biblical interpretations of the cosmos. Galileo's discoveries, which supported Copernicus' heliocentric theory, were seen as a challenge to the Church's authority and its interpretation of Scripture. In 1632, Galileo published his work Dialogue concerning the two chief world systems, in which he presented evidence for the heliocentric model. The Church, alarmed by Galileo's assertions, condemned his work. In 1633, Galileo was tried by the Inquisition and found guilty of heresy for promoting the Copernican system. He was forced to recant his views and spent the remainder of his life under house arrest. The conflict between Galileo and the Church marked a significant moment in the history of science, illustrating the tension between religious authority and scientific discovery. Despite the opposition, Galileo's work eventually contributed to the acceptance of the heliocentric model and to the broader scientific revolution, which would forever change our understanding of the universe. Isaac Newton and the link between the moon and gravity. One of the most significant advances in our understanding of the moon came with the work of Isaac Newton in the late 17th century. Newton's law of universal gravitation, published in his monumental work Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, in 1687, provided a mathematical explanation for the motions of celestial bodies, including the moon. Newton's theory of gravity explained how the moon's orbit around the Earth is governed by the same force that causes objects to fall to the ground. According to Newton, every mass in the universe exerts a gravitational pull on every other mass. The moon's motion is a result of the gravitational attraction between the Earth and the moon, causing the moon to orbit Earth. This groundbreaking theory not only clarified the nature of the moon's movement but also provided a unified explanation for both terrestrial and celestial phenomena. Newton's work laid the foundation for modern physics and astronomy, transforming the way we understood the forces that govern the universe. His theory of gravity also paved the way for later developments in space exploration and the study of the moon. The moon, once thought to be a mysterious and distant object, was now understood to be part of a complex and predictable system governed by universal laws. We have explored the evolution of our understanding of the moon through the work of early astronomers and scientists. Ptolemy's geocentric model laid the groundwork for centuries of astronomical thought, while Copernicus' heliocentric theory challenged the traditional view of the universe. The discoveries made by Galileo using the telescope revealed the moon's surface features and provided important evidence for the heliocentric model, despite opposition from the Church. Finally, Isaac Newton's law of gravity linked the moon's motion to the same principles that govern objects on Earth, offering a comprehensive understanding of the moon's role in the cosmos. These early scientific advancements not only deepened our understanding of the moon but also transformed our view of the entire universe. The space race and the Apollo missions. The space race, which took place primarily during the 1960s and early 1970s, was not only a scientific and technological competition but also a political struggle between the United States and the Soviet Union. The Cold War context deeply shaped the priorities of both superpowers as they sought to demonstrate their technological superiority, national pride, and ideological influence on a global stage. The moon became a central symbol of this competition, with both nations eager to prove their capabilities by reaching and exploring the lunar surface. In this section, we will explore the Cold War context of the space race, examining the significance of the moon as a political and technological prize. We will also delve into the Soviet Union's achievements in space, particularly the lunar program, and to the American response through the Mercury and Gemini programs, leading up to the historic Apollo 11 landing in 1969. Cold War context: the moon as a political and technological prize. The Cold War was a period of intense geopolitical tension between the United States and the Soviet Union, marked by ideological, military, and technological rivalry. Both superpowers sought to prove the superiority of their respective political and economic systems, capitalism versus communism, through various means, including the arms race, the space race, and the influence of global alliances. The launch of Sputnik 1 by the Soviet Union in 1957, the world's first artificial satellite, marked the beginning of the space race. Sputnik's successful orbit of Earth stunned the United States and the rest of the world, as it demonstrated the Soviet Union's capability to send objects into space. This achievement gave the Soviets a significant technological and propaganda advantage, prompting the US to respond with efforts to catch up and surpass Soviet space achievements. In this high-stakes atmosphere, the moon became a particularly important goal. Reaching the moon, or at least demonstrating the ability to send a mission to the lunar surface, would be a powerful symbol of national superiority. For both the United States and the Soviet Union, success in space was not only about scientific exploration but also about sending a message to the world that they possessed the technological prowess to conquer the final frontier. In 1961, President John F. Kennedy set a clear and ambitious goal for the United States: to land a man on the moon and return him safely to Earth before the decade was out. His famous speech at Rice University emphasized that space exploration was not just a matter of technological progress but also a matter of national pride and leadership. Kennedy's vision galvanized the American space program and shifted the focus of the Cold War to the moon. Soviet achievements: Luna program, first lunar orbit, first impact. While the United States was gearing up for a manned lunar mission, the Soviet Union made significant strides in its own lunar exploration program. The Soviet lunar program was a series of robotic spacecraft missions designed to explore the moon, and it achieved several major milestones in the early years of the space race. One of the most notable Soviet achievements came in 1959, when the Luna 1 spacecraft became the first human-made object to reach the moon. Though it did not land, it passed within 5,995 kilometers of the lunar surface and became the first spacecraft to reach the moon's gravitational field. The successful flyby marked a key milestone in space exploration and was a major Soviet triumph. In 1959, the Soviets followed up with Luna 2, which achieved the first successful impact on the moon's surface. Luna 2 crash-landed on the moon on September 13, 1959, and became the first human-made object to reach the moon's surface, leaving a lasting mark in the history of space exploration. This was an enormous accomplishment, but the United States still had not yet reached the moon with any spacecraft. In 1966, the Soviet Union achieved another remarkable milestone with Luna 9, which became the first spacecraft to perform a soft landing on the moon and transmit photographs of its surface back to Earth. The images captured by Luna 9 were groundbreaking, showing for the first time what the moon's surface looked like from the ground. While these achievements were significant, the Soviet Union's emphasis on robotic exploration of the moon was eventually overshadowed by the United States' determination to land humans on the lunar surface. Nevertheless, the Soviet Union's early successes in space contributed to the overall momentum of lunar exploration and highlighted the intense competition between the two superpowers. American response: Mercury and Gemini programs leading up to Apollo. In response to the Soviet Union's early successes, the United States launched its own space programs, starting with the Mercury program, followed by the Gemini program, and culminating in the Apollo program. These efforts were part of the broader space race, and each program built on the successes of the last, gradually paving the way for the historic achievement of landing astronauts on the moon. Mercury program: the first American astronauts. The Mercury program was the United States' first manned spaceflight program, initiated by NASA in 1958. Its primary objective was to put a human into space and orbit the Earth. The program began in earnest in 1959, and in 1961, Alan Shepard became the first American to travel into space aboard Freedom 7. Shepard's flight, which lasted just over 15 minutes, was a critical first step in the United States' push to match the Soviet Union's space achievements. The Mercury program was followed by the Gemini program, which had more ambitious goals. The Gemini spacecraft were designed to hold 2 astronauts and were equipped with more advanced technology, including the ability to perform spacewalks, extravehicular activities, and to dock with other spacecraft, crucial skills for a future lunar mission. Gemini program, preparing for the moon. The Gemini program ran from 1961 to 1966, and it involved a series of 12 missions that laid the groundwork for the Apollo program. The Gemini spacecraft were designed to test the capabilities needed for a successful mission to the moon, such as rendezvousing with another spacecraft in orbit and conducting long-duration flights. One of the most notable milestones of the Gemini program was the Gemini 8 mission in 1966, which achieved the first successful docking of 2 spacecraft in orbit. Although the mission was cut short due to an in-flight emergency, it proved that astronauts could dock with other spacecraft, a vital skill for landing on the moon. Another key achievement came with Gemini 12 in November 1966, which demonstrated the ability of astronauts to perform spacewalks, a skill that would later be required for lunar missions. With these successes, NASA gained the experience necessary to launch the Apollo program, which would focus on landing astronauts on the moon. Apollo 11 landing, Neil Armstrong and Buzz Aldrin's first steps. The Apollo program, launched in 1961 by President John F. Kennedy, was the culmination of the United States' efforts to beat the Soviet Union to the moon. After a series of preparatory missions, Apollo 1 to Apollo 10, the momentous Apollo 11 mission took place in 1969. On July 20, 1969, the Apollo 11 lunar module, named Eagle, touched down on the moon's surface. Neil Armstrong became the first human to set foot on the lunar surface, followed shortly by Buzz Aldrin. Armstrong's famous words, "That's one small step for man, one giant leap for mankind," were broadcast live to millions of people around the world. The success of the Apollo 11 mission was a defining moment in human history. It marked the realization of a dream that had seemed unattainable just a few decades earlier. The mission's primary scientific goal was to collect samples from the lunar surface, and it also included experiments designed to study the moon's environment. Armstrong and Aldrin spent a total of 21 hours on the lunar surface before returning to the command module, piloted by Michael Collins, who remained in lunar orbit. The achievement of Apollo 11 was not only a victory for the United States but also a triumph for humanity, demonstrating what could be achieved through international cooperation and human ingenuity. The success of the mission led to additional Apollo lunar landings, with Apollo 12, Apollo 14, Apollo 15, Apollo 16, and Apollo 17 furthering our knowledge of the moon's geology and environment. Mercury and Gemini programs leading up to Apollo. Before the United States could land a man on the moon, NASA needed to establish the foundational spaceflight technologies and knowledge that would make such a monumental feat possible. The Mercury and Gemini programs played crucial roles in this process, serving as the necessary precursors to the Apollo missions. Mercury program, the first American astronauts. The Mercury program, which ran from 1958 to 1963, was the United States' first manned spaceflight program. Its goal was simple yet ambitious: to put an American astronaut into space and orbit the Earth. The program consisted of 6 crewed flights, with Alan Shepard becoming the first American in space on May 5, 1961, aboard Freedom 7. Shepard's flight, lasting only 15 minutes, was a suborbital mission, but it was an essential first step in the broader goal of reaching the moon. The Mercury program marked several key milestones. John Glenn's orbital flight on February 20, 1962, was the first time an American astronaut completed a full orbit of Earth, proving that human spaceflight could be sustained for longer durations. The Mercury spacecraft, though small and limited in capabilities, proved that humans could survive and function in space for short periods. These early flights provided critical data on space radiation, the effects of weightlessness, and the performance of spacecraft systems. These successes were a clear indication that humanity had the potential to journey further into space. However, Mercury's limited scope left many unanswered questions, particularly about spaceflight duration, navigation, and complex maneuvers needed for future lunar exploration. Gemini program, paving the way for the moon. Building on the lessons of Mercury, NASA launched the Gemini program from 1962 to 1966, which aimed to tackle the more complex challenges of space exploration. The Gemini spacecraft could carry 2 astronauts and had the ability to support longer missions, lasting up to 2 weeks in space. The key objectives of the Gemini program included space rendezvous and docking, a critical task for the Apollo missions, as astronauts would need to dock with the lunar module while in orbit around the Moon. Extravehicular activity, EVA spacewalks were essential for Apollo missions, particularly for tasks such as repairing spacecraft and conducting scientific experiments on the lunar surface. Long-duration spaceflight. The Gemini program extended the duration of missions, allowing astronauts to stay in space for much longer periods, laying the groundwork for the longer Apollo missions. Notable milestones of the Gemini program included Gemini 7, which achieved the record for longest spaceflight at the time, lasting 14 days. Gemini 8, which completed the first successful docking of 2 spacecraft in orbit. Gemini 12, which demonstrated the ability to perform spacewalks and manage complex space operations, essential for landing on the Moon. By the end of the Gemini program, NASA had acquired the expertise required for the lunar landing. The program's success in mastering orbital maneuvers, spacecraft rendezvous, and spacewalks was a crucial step toward Apollo's more ambitious goals. Apollo 11 landing, Neil Armstrong and Buzz Aldrin's first steps. The culmination of the Mercury and Gemini programs and the ambitious vision set by President John F. Kennedy was realized in 1969 when the United States achieved the unthinkable, landing humans on the Moon. The Apollo 11 mission was the first crewed lunar landing, and it marked a historic moment for humanity. On July 20, 1969, the Eagle lunar module, part of the Apollo 11 spacecraft, successfully landed on the surface of the Moon. The astronauts aboard, Neil Armstrong, Buzz Aldrin, and Michael Collins, had made the long journey to the Moon and were about to make history. Neil Armstrong became the first person to set foot on the lunar surface, uttering his famous words, "That's one small step for man, one giant leap for mankind." Buzz Aldrin followed shortly after, becoming the second human to walk on the Moon. Michael Collins remained in lunar orbit aboard the Columbia Command Module, keeping the spacecraft in position to return the astronauts to Earth. The Apollo 11 landing was the fulfillment of President Kennedy's goal to reach the Moon within a decade, and it was a moment of national pride for the United States. The successful landing also provided unprecedented opportunities for scientific discovery. The astronauts spent over 21 hours on the Moon's surface, conducting experiments, taking photographs, and collecting samples. The Apollo 11 astronauts returned with 47.5 pounds, 21.5 kilograms, of lunar material, which included soil and rock samples. These samples would become invaluable to scientists in understanding the composition of the Moon and its geological history. Scientific discoveries and Moon samples. The scientific value of the lunar samples collected during the Apollo missions was immense. In total, the Apollo program brought back over 800 pounds, about 360 kilograms, of lunar rocks, soil, and core samples. These materials were analyzed by scientists and provided critical insights into the Moon's formation, composition, and geological activity. Key discoveries from the Apollo 11 mission and subsequent Apollo missions include lunar composition. The Moon's surface was found to be made of rocks and minerals that were chemically similar to Earth's, but with some key differences, such as a lack of water and a high concentration of an element called titanium. This suggested that the Moon had been subjected to extreme conditions during its formation. Age of the Moon. The lunar rocks collected by the Apollo astronauts helped scientists determine that the Moon is about 4.5 billion years old, roughly the same age as the Earth, supporting the theory that the Moon and Earth were formed from similar material. Volcanic activity. Some of the lunar samples indicated that the Moon had once been volcanically active. Evidence of ancient volcanic rock suggested that the Moon had experienced a phase of magma eruptions in its early history, although it was now geologically inactive. Lunar geology. The analysis of the Moon's surface also helped scientists understand its geological processes, including the presence of lunar regolith, a layer of loose, fragmented material that covers much of the Moon's surface. The study of these materials has provided valuable insights into the processes that shape planetary bodies. Isotopic analysis. The The isotopic composition of lunar samples revealed that the moon has a similar composition to Earth, further supporting the idea that the moon formed from material ejected by a massive collision between Earth and a hypothetical planet-sized object known as Theia. This theory, known as the giant impact hypothesis, was bolstered by the chemical similarities between the Earth and Moon's rocks. Later Apollo missions and their contributions to lunar science. Following the success of Apollo 11, 6 more Apollo missions landed on the Moon between 1969 and 1972. Each of these missions contributed to our understanding of the Moon and furthered scientific research. Notable missions included Apollo 12, 1969, the second successful lunar landing. Apollo 12 was tasked with gathering more detailed samples from the Moon's surface and studying the effects of lunar weathering. The astronauts, Charles Conrad and Alan Bean, collected 75 pounds, 34 kilograms, of lunar samples, including rocks from the Moon's Surveyor 3 spacecraft, which had landed on the Moon 3 years earlier. Apollo 14, 1971. This mission included astronauts Alan Shepard and Edgar Mitchell, who spent over 33 hours on the Moon. They conducted experiments and collected samples, including a core sample from the lunar surface, which provided new insights into the composition of the Moon's interior. Apollo 15, 1971. This mission was the first to use a lunar rover, allowing astronauts David Scott and James Irwin to explore a broader area of the Moon. They collected 170 pounds, 77 kilograms, of samples, including rocks from the Moon's Hadley Rill, a deep valley believed to be formed by ancient lava flows. Apollo 16, 1972. The astronauts John Young and Charles Duke spent 71 hours on the Moon, exploring the Descartes Highlands and collecting lunar samples that helped scientists understand the Moon's early volcanic activity. Apollo 17, 1972. The final Apollo mission, Apollo 17, was the most extensive of all the lunar landings. Astronauts Eugene Cernan and Harrison Schmitt collected more than 243 pounds, 110 kilograms, of lunar samples, providing a wealth of new data on the Moon's geological history. Apollo 17 also marked the last time humans set foot on the Moon. The Apollo 11 mission was the first to achieve the remarkable goal of landing humans on the Moon, followed by several more missions that brought back invaluable scientific discoveries. From the composition of the lunar surface to the insights into the Moon's volcanic past, the Apollo program vastly expanded our understanding of the Moon and its formation. The lunar samples, analyzed over decades, continue to contribute to scientific research today. The Apollo program remains one of the most significant achievements in human history, not only for its scientific contributions but also for the way it united humanity in a shared pursuit of knowledge and exploration. The Moon's influence on culture and art. The Moon has long been a source of inspiration in various forms of art, literature, and cinema. Its mystery, beauty, and influence on human existence have captured the imagination of countless individuals across cultures and time periods. As humanity's closest celestial neighbor, the Moon is not only central to the development of scientific thought but also plays a significant role in shaping cultural and artistic expression. From early stories of lunar exploration to its depiction in science fiction films, the Moon has become a symbol of both human ambition and mystery. In this section, we explore the role of the Moon in literature, particularly through 2 visionary works, as well as its portrayal in some of the most iconic science fiction films. Jules Verne's From the Earth to the Moon. One of the earliest works to delve into the concept of lunar travel was Jules Verne's novel, From the Earth to the Moon, 1865. Known as one of the founding fathers of science fiction, Verne was a pioneer in exploring scientific possibilities within the realm of fiction. His novel envisioned the possibility of space travel long before humans had the technology to venture beyond Earth's atmosphere. In From the Earth to the Moon, Verne imagined a group of American adventurers who planned to travel to the Moon by launching a spacecraft from a giant cannon. The story follows the development of this ambitious project, focusing on the technical details, challenges, and the personalities of the individuals involved. Although the idea of firing a spacecraft from a cannon seems absurd by today's standards, Verne's vision was groundbreaking for its time, suggesting that human beings could one day explore the Moon. Verne's novel highlighted themes of scientific progress, human curiosity, and the desire to reach beyond the stars. It was a product of the 19th century's fascination with exploration and technological advancement, reflecting the growing understanding of science and engineering. Verne's imagination, paired with his methodical research into contemporary scientific knowledge, made his vision of lunar travel seem plausible to many readers at the time. In many ways, From the Earth to the Moon can be seen as the precursor to later works of science fiction, setting the stage for more sophisticated depictions of space travel and inspiring future generations of writers, engineers, and explorers. The influence of this novel on space exploration is not just limited to literature but extends to actual space programs. For example, the Apollo 11 mission, which achieved the first human landing on the Moon in 1969, mirrored some of the themes and ambitions that Verne described more than a century earlier. H.G. Wells' The First Men in the Moon. Another literary classic that explores the concept of lunar exploration is H.G. Wells' The First Men in the Moon, 1901. A key figure in the development of modern science fiction, Wells brought a more scientific and speculative approach to the genre. Unlike Verne's fantastical canon-driven space travel, Wells took a more imaginative route, proposing the idea of a spacecraft that could fly to the Moon using advanced technology and propulsion. In The First Men in the Moon, Wells introduces the character of Professor Caver, a brilliant scientist who invents a substance called caverite, which negates the force of gravity and allows for space travel. The story follows the professor and his companion, Mr. Bedford, as they travel to the Moon, where they discover an alien civilization living beneath the Moon's surface. Wells' novel addresses many of the themes that would become central to later science fiction stories, including the exploration of unknown worlds, the encounter with alien species, and the consequences of technological advancement. The lunar journey is depicted not just as a scientific adventure but also as a philosophical one. Wells uses the Moon as a backdrop for exploring ideas about human nature, civilization, and the potential for discovery beyond Earth. One of the most significant aspects of The First Men in the Moon is its portrayal of the Moon as a strange and alien place, filled with secrets and dangers. Unlike Verne's idealized vision, Wells presents the Moon as a complex and somewhat hostile environment, complete with an advanced alien society that lives below the surface. This depiction of the Moon as a place of mystery and wonder would become a recurring theme in later science fiction literature and films. Wells' influence on science fiction is profound, and his imaginative use of the Moon as a setting for exploring broader social and philosophical issues made The First Men in the Moon an important work in the genre. The novel continues to inspire readers and filmmakers today, and its themes resonate with contemporary questions about the potential for human life beyond Earth. The Moon in science fiction films. The influence of the Moon on culture and art is perhaps most visibly reflected in the realm of science fiction films, where it has become a central symbol of exploration, human ambition, and mystery. Over the years, many iconic films have used the Moon as a setting for imaginative storytelling, exploring the possibilities of lunar travel, extraterrestrial life, and humanity's future in space. Three particularly influential films, 2001, A Space Odyssey, Moon, and Interstellar, offer compelling portrayals of the Moon and its symbolic significance in the broader narrative of human exploration. 2001, A Space Odyssey, 1968. Stanley Kubrick's 2001, A Space Odyssey, is one of the most influential films in the history of science fiction. Released in 1968, the film takes audiences on an interstellar journey that begins with a mysterious monolith discovered on the Moon. This artifact, which appears to be of extraterrestrial origin, serves as a catalyst for the film's exploration of human evolution and the potential for contact with advanced alien civilizations. The opening scenes of the film depict the Moon as a place of profound mystery. When a team of astronauts discovers the monolith on the Moon's surface, it triggers a sequence of events that ultimately leads to humanity's exploration of deeper space. The Moon, in Kubrick's vision, is not just a barren rock but a crucial stepping stone in humanity's journey toward greater knowledge and understanding of the cosmos. 2001, A Space Odyssey, is not just a film about space exploration. It is a philosophical meditation on humanity's place in the universe and the potential for transcendent discovery. The moon, as the closest celestial body to Earth, serves as the gateway to a larger cosmic narrative. The film's use of the moon as a symbol of both the unknown and the next phase of human evolution continues to resonate with audiences today, offering a timeless exploration of human curiosity and the desire to explore the stars. Moon, 2009. The 2009 film Moon, directed by Duncan Jones, takes a more intimate and existential approach to the concept of lunar exploration. The story follows Sam Bell, a man who works alone on a lunar base as part of a mining operation. As his 3-year shift nears its end, Sam begins to experience strange occurrences that lead him to question his own identity and the nature of the corporation he works for. Unlike the grandiose space operas of the past, Moon focuses on the psychological and emotional aspects of life on the moon. The isolated, desolate environment of the lunar surface serves as a backdrop for exploring themes of loneliness, memory, and identity. The moon in this film is not just a symbol of adventure but also a place of confinement and existential crisis. The film's minimalist approach to the lunar setting, paired with its exploration of human isolation, makes Moon a thought-provoking meditation on the consequences of technological advancement and corporate greed. It offers a more personal and introspective view of space exploration, showing how even the moon, once a symbol of human achievement, can become a site of profound disillusionment. Interstellar, 2014. Another major science fiction film that prominently features the moon is Christopher Nolan's Interstellar, 2014. In this film, the moon plays a symbolic role in the broader narrative of humanity's search for a new home. Set in a future where Earth is facing environmental collapse, Interstellar follows a group of astronauts who embark on a journey through a wormhole to find a habitable planet for humanity. In the early stages of the film, the moon serves as a reminder of humanity's past achievements in space exploration. The story opens with references to the Apollo missions and the belief that the moon could have been the key to saving humanity. However, the moon also symbolizes the difficulties that space exploration faces in the future. Resources are depleted, and the dream of lunar colonization seems like a distant memory. The moon's role in Interstellar is less about physical exploration and more about the broader theme of human survival and the search for hope beyond Earth. Interstellar uses the moon as both a tangible and symbolic presence, representing both the heights of human achievement and the harsh realities of our dependency on Earth's resources. Its treatment of the moon contrasts with its treatment of distant stars and galaxies, underscoring the film's exploration of time, space, and the human spirit. In both literature and film, the moon has served as a powerful symbol of humanity's desire to reach beyond the confines of Earth, explore the unknown, and confront existential questions about life, identity, and the future. From Jules Verne's speculative lunar travel to the philosophical explorations of Kubrick and Nolan, the moon remains a key cultural and artistic figure. Whether as a site of adventure, a symbol of human ambition, or a reflection of isolation and disillusionment, the moon continues to inspire and provoke deep reflections on the nature of human exploration and our place in the universe. The moon's influence on culture and art continued. The moon has also inspired music across centuries, from the romantic strains of classical compositions to the revolutionary sounds of modern rock. Its quiet beauty, ethereal glow, and association with mystery and emotion have made it an enduring muse for composers and musicians alike. Beyond its role in art and fiction, the moon's symbolism also carries deep meaning in philosophy and psychology, where it often represents the unconscious, duality, and the cyclical nature of life. In this section, we explore how the moon has shaped the music world, including iconic works like Beethoven's Moonlight Sonata and Pink Floyd's Dark Side of the Moon, as well as its broader philosophical and psychological symbolism. Classical compositions. Beethoven's Moonlight Sonata. One of the most famous classical pieces associated with the moon is Ludwig van Beethoven's Piano Sonata No. 14 in C-sharp minor, Op. 27 No. 2, more commonly known as the Moonlight Sonata. Written in 1801, this composition is one of Beethoven's most well-known works, largely due to its evocative and haunting melodies that many listeners associate with the peaceful, reflective qualities of moonlight. The sonata was given its popular name after the German music critic Ludwig Rellstab wrote in 1832 that the piece reminded him of moonlight shining upon the lake. This association, though not something Beethoven himself intended, has endured for centuries. The first movement of the sonata, marked Adagio sostenuto, is especially noted for its delicate, almost hypnotic rhythm, evoking the calm, serene nature of a moonlit night. The music's slow pace and gentle flow mirror the stillness and tranquility often attributed to the moon, capturing a sense of quiet reflection and solitude. However, Beethoven's work is not merely a literal interpretation of the moon, but also a representation of deeper emotional states. The Moonlight Sonata evokes feelings of melancholy and introspection, qualities often linked to the darker aspects of the moon's influence in human culture. The piece contrasts with the more upbeat, joyful elements of Beethoven's other works, offering a moment of quiet beauty and emotional depth that resonates with listeners. Beyond its association with the moon, Beethoven's Moonlight Sonata also highlights his ability to convey powerful emotion through music. The piece captures a range of human experiences, from longing and sorrow to the fleeting moments of peace and clarity. Over the years, it has become a cultural touchstone, frequently featured in films, advertisements, and performances, further cementing its connection to the moon's symbolism in art and music. Modern music, Pink Floyd's Dark Side of the Moon. In more recent times, the moon has continued to serve as a source of inspiration in music, especially in the world of rock and psychedelic music. One of the most iconic albums to be inspired by the moon is Pink Floyd's The Dark Side of the Moon, released in 1973. This groundbreaking album is widely regarded as one of the greatest and most influential albums of all time, both musically and thematically. The Dark Side of the Moon explores complex themes such as mental illness, the passage of time, existential questioning, and the pressures of modern life, all while using the moon as a central symbol. The title itself reflects the album's exploration of the darker, hidden aspects of the human experience, the dark side of both the moon and the psyche. Musically, Pink Floyd uses the moon as a metaphor for the unknown, the subconscious, and the inevitable challenges that life presents. The album's atmospheric sound, lush arrangements, and complex layering create a sense of mystery, echoing the moon's enigmatic presence in the night sky. The opening track, Speak to Me, with its eerie sounds and disorienting effects, sets the tone for the album, creating a sense of disconnection and exploration into the unknown. Other tracks, such as Breathe and Time, address the passage of time, existential angst, and the fleeting nature of life, all of which are often symbolically tied to the moon's phases and its cyclical nature. One of the most famous songs from the album, Eclipse, speaks directly to the cyclical and dual nature of existence, with lyrics that reflect on the interconnectedness of all aspects of life, from light and dark to birth and death. Just as the moon's phases are constantly in motion, Pink Floyd's album reflects the cyclical nature of human experiences, exploring the intersection of light and dark, consciousness and unconsciousness, and sanity and madness. The enduring popularity of The Dark Side of the Moon speaks to its universal themes and the profound connection it has made between the listener and the concept of the moon. Not only is the album a sonic exploration of the moon's symbolism, but it also reflects the band's ability to fuse music, philosophy, and psychology in a way that resonates deeply with audiences worldwide. The moon as a symbol in philosophy and psychology. Beyond its presence in music and the arts, the moon has played a significant role in both philosophy and psychology, often representing deeper concepts of duality, the unconscious mind, and the passage of time. Philosophers and psychologists have long been fascinated by the moon's influence on human thought, behavior, and perception. In philosophy, the moon often symbolizes duality, the contrast between light and dark, known and unknown, conscious and unconscious. This idea of dualism has been explored by many thinkers throughout history, from Plato to Carl Jung. The moon's phases represent cycles of change and transformation, symbolizing both the constants and the impermanence of life. The idea that the moon reflects sunlight, yet retains its own distinct light, has also been used metaphorically to describe the relationship between the conscious and unconscious minds, where the conscious mind may illuminate some aspects of experience, but much of the psyche remains hidden in shadow. In psychology, the moon has long been associated with the unconscious, emotions, and the ebb and flow of human feelings. Carl Jung, one of the most influential psychologists of the 20th century, referred to the moon as a symbol of the shadow, the unconscious part of the psyche that holds repressed thoughts, desires, and memories. For Jung, the moon represented the inner world of the individual, in contrast to the sun's representation of the conscious, outward-focused self. Additionally, the moon has often been connected to the concept of cyclical change in life. The moon's phases, from the new moon to the full moon and back again, are often seen as symbols of the cycles of life, growth, decay, and renewal. This cyclical nature has profound psychological implications, as it suggests that life is not linear but rather marked by repeating patterns and transformations. The moon's connection to feminine energy and the concept of fertility also ties it to cycles of birth, creation, and renewal, aligning with the broader psychological archetype of the Great Mother, a figure representing both nurturing and destruction. Moreover, the moon's association with emotional states is evident in the word lunacy, which derives from the Latin word for moon, luna. Historically, it was believed that the full moon could cause madness or erratic behavior, a belief that persists in modern popular culture. The idea that the moon could influence human emotions, particularly during the full moon, speaks to the deep psychological connection between the moon and human nature. Modern lunar science and future missions. The exploration of the moon has entered a new and exciting phase, driven by both government space agencies and private companies. In recent decades, lunar science has advanced significantly, revealing new insights about the moon's composition, its potential resources, and its role in human space exploration. Missions such as NASA's Lunar Reconnaissance Orbiter, LRO, China's Chang'e program, and NASA's Artemis initiative have played a key role in expanding our understanding of the moon. Moreover, the search for water on the moon has become one of the most crucial areas of study, as it has the potential to support future lunar habitats. Private companies like SpaceX and Blue Origin have also become significant players in the space race, envisioning the moon as a critical stepping stone for future exploration, including the ultimate goal of reaching Mars. In this section, we will explore these discoveries and developments, examining how they pave the way for a permanent human presence on the moon and the broader possibilities for space colonization. Discoveries from recent missions, LRO, Chang'e, Artemis program. Modern lunar exploration has benefited from the cutting-edge technology of spacecraft and scientific instruments, which have provided an unprecedented view of the moon's surface and interior. Among the most notable missions, the Lunar Reconnaissance Orbiter, LRO, part of NASA's lunar science program, has been crucial in mapping the moon's surface in detail. Launched in 2009, the LRO has produced high-resolution images and data that have helped scientists understand the moon's topography, surface composition, and potential landing sites for future missions. One of the most groundbreaking discoveries made by the LRO was the identification of water ice in the moon's polar regions, which has significant implications for future lunar exploration. More on this later. China's Chang'e program, named after the Chinese moon goddess, has also made significant strides in lunar exploration. Since the program's inception, it has achieved major milestones, including the successful landing of Chang'e 4 on the far side of the moon in 2019, a first for humanity. Chang'e 5, launched in 2020, was a particularly important mission as it successfully returned lunar samples to Earth, marking the first time in more than 40 years that lunar material was brought back from the moon. These missions have provided vital information about the moon's geological history, including insights into its volcanic activity and the composition of its soil, and have laid the groundwork for future lunar exploration by China. The Artemis program, led by NASA, is one of the most ambitious lunar exploration initiatives in recent history. The program aims to return astronauts to the moon by 2025, with a goal of establishing a sustainable human presence by the end of the decade. Artemis will be the first mission to send humans to the lunar South Pole, an area of great interest because it is believed to contain substantial deposits of water ice. Artemis will not only explore new regions of the moon but will also serve as a testing ground for new technologies, such as advanced lunar landers and habitats, that could be used for Mars missions in the future. These recent missions have not only enhanced our understanding of the moon but have also provided the necessary foundation for future human exploration and habitation. The search for water on the moon. One of the most exciting developments in modern lunar science is the discovery of water on the moon, particularly in the form of ice. Water is essential for long-term human habitation, as it can be used for drinking, growing food, and producing oxygen. Additionally, water can be split into hydrogen and oxygen, which are key components for rocket fuel, making it a potential resource for future space missions. The discovery of water ice at the moon's poles has sparked tremendous interest among scientists. Observations by the Lunar Reconnaissance Orbiter (LRO), as well as the Chandrayaan-1 mission from India, have confirmed the presence of water molecules on the lunar surface, especially in permanently shadowed regions near the poles, where sunlight never reaches. These areas are incredibly cold, with temperatures dropping to as low as -250 degrees Fahrenheit, -157 degrees Celsius, creating the perfect conditions for water to freeze and accumulate over millions of years. The water found on the moon could play a pivotal role in establishing sustainable lunar bases. If future missions are able to mine and extract this water, it could be used in a variety of ways, from supporting life systems to providing rocket fuel for deep space missions. NASA's Artemis program is heavily focused on exploring the potential of these lunar resources, and the idea of extracting water from the moon is already a key aspect of its mission planning. In addition to water ice, scientists have also identified other valuable resources, such as helium-3, a potential fuel for future nuclear fusion reactors, and a variety of minerals that could be used for construction and manufacturing on the moon. As technology advances, mining these resources could become a viable way to support human colonies on the moon and beyond. The possibility of permanent moon bases and colonization. With the advent of new technologies and discoveries, the idea of establishing a permanent human presence on the moon is becoming increasingly feasible. A sustainable moon base could serve as a research outpost, a launching pad for deeper space exploration, and a testbed for future technologies that could be used on Mars and beyond. The establishment of such a base would not only demonstrate humanity's ability to live off-planet but also pave the way for long-term space colonization. One of the most exciting aspects of the Artemis program is its goal of creating a sustainable lunar base by the late 2020s or early 2030s. This base will likely be built near the lunar South Pole, where there is abundant water ice. The base would serve as a hub for scientific research, resource extraction, and as a starting point for further exploration of the moon and beyond. The infrastructure required for such a base will include lunar habitats, energy generation systems, likely powered by solar or nuclear energy, and the ability to produce water, oxygen, and food locally. One key challenge to establishing a permanent base on the moon is the moon's harsh environment, with extreme temperature fluctuations and a lack of atmosphere to protect against radiation. Future lunar habitats will need to be well shielded, potentially utilizing the moon's natural resources to create protective structures. 3D printing technologies are being explored as a means of constructing lunar habitats using materials found on the moon itself, such as regolith, the moon's loose surface material. Another possibility for moon colonization involves the concept of lunar tourism, which could open the door to private ventures aimed at establishing semi-permanent bases on the moon. As the technology develops, we may see commercial ventures offering trips to the moon for both research and leisure, similar to how private companies are already planning space tourism to low Earth orbit. Private sector involvement, SpaceX and Blue Origin. In recent years, the private sector has become increasingly involved in space exploration, with companies like SpaceX and Blue Origin taking the lead in developing technologies for lunar exploration and colonization. SpaceX, founded by Elon Musk, has made significant strides in advancing space travel with its Starship program. Starship is designed to carry large numbers of astronauts and cargo to the moon, Mars, and beyond. SpaceX's involvement in the Artemis program as a key partner in providing lunar transportation highlights the growing role of private companies in space exploration. Musk's long-term vision is to establish a human settlement on Mars, and the Moon could serve as a critical stepping stone for this ambition. SpaceX's reusable rocket technology has already revolutionized the cost of space travel, and the company's focus on making space travel more affordable and efficient is likely to accelerate the timeline for lunar colonization. Blue Origin, founded by Jeff Bezos, has also been developing technologies for lunar exploration, including its Blue Moon lander, which is designed to deliver payloads to the Moon's surface. Like SpaceX, Blue Origin envisions the Moon as a stepping stone for future exploration of Mars and beyond. Bezos has proposed the creation of O'Neill colonies, large space habitats that could be built in Earth's orbit or on the Moon, supporting a growing human population in space. Blue Origin's vision aligns with the broader concept of using the Moon as a launchpad for the human expansion into the solar system. How the Moon could be a stepping stone for Mars missions. The Moon has long been considered a potential stepping stone for the next phase of human space exploration, Mars. Establishing a permanent presence on the Moon could provide the necessary infrastructure, technologies, and experience to tackle the more challenging goal of reaching and colonizing Mars. The Moon shares many challenges with Mars, including a lack of atmosphere, harsh environmental conditions, and limited resources. By overcoming these challenges on the Moon, we can develop solutions that can be applied to Mars. Additionally, the Moon's proximity to Earth makes it an ideal location for testing life support systems, resource extraction technologies, and deep space travel technologies before venturing to Mars. By establishing a permanent base on the Moon, we can also gain valuable experience in living and working in space for extended periods, which will be essential for the longer duration of missions to Mars. The Moon also offers a unique advantage when it comes to launching missions to Mars. The lower gravity on the Moon compared to Earth means that it would take less energy to launch spacecraft from the Moon's surface. By building refueling stations on the Moon, future missions to Mars could be launched more efficiently, using the Moon as a refueling point for rockets heading deeper into space. As we have explored throughout this journey, the Moon has played a profound and multifaceted role in shaping human history, science, and culture. From its mythical representation across ancient civilizations to its pivotal role in modern science and space exploration, the Moon has inspired awe and curiosity for millennia. It has served as a symbol of mystery and wonder, influencing everything from literature and art to scientific discoveries and technological advancements. Its influence is far-reaching, extending into every corner of human knowledge, and it continues to serve as a canvas for our imaginations, as well as a beacon for our future. The Moon has always been an object of fascination. In mythology, it was revered as a deity, like the Mesopotamian god Sin or the Greek god Selene, representing mystery, transformation, and the forces of nature. Over centuries, it was viewed as a source of guidance for ancient cultures, helping them mark time through lunar calendars and guiding them in rituals and navigation. The Moon was not only a celestial body but a symbol woven deeply into the cultural fabric of humanity, embodying the cycles of life, death, and rebirth. In the realm of science, the Moon's influence cannot be overstated. From the ancient theories of the cosmos to the revolutionary work of Galileo and Newton, the Moon has been central to our understanding of the universe. The dawn of space exploration, marked by the Apollo missions, has allowed humanity to set foot on the lunar surface and further unravel its mysteries. Today, we are in an exciting new chapter of lunar exploration, with modern missions like Artemis, Chang'e, and LRO paving the way for humanity's return to the Moon, and perhaps the beginning of a permanent presence there. The Moon's scientific significance has never been more apparent. It is not merely a distant, cold rock orbiting our planet. It holds vital clues to the early history of the Earth, the formation of the solar system, and the potential for future space exploration. The discovery of water on the Moon, in particular, has opened up new avenues for sustainable lunar habitats, potentially offering a way to support future space exploration and even colonization. The Moon could become the springboard from which humanity launches missions to Mars and beyond, making it an essential stepping stone in the quest to become a multiplanetary species. As we look to the future, the moon will continue to be at the center of humanity's aspirations. With private companies like SpaceX and Blue Origin entering the race, the possibility of establishing permanent lunar bases becomes more tangible than ever before. The moon will not only serve as a destination for scientific discovery but as a resource hub, a testbed for space technologies, and a symbol of human innovation and determination. It could become a stepping stone for the exploration of Mars, where humanity's next great leap into the cosmos will take place. In the near future, we may see a moon that is not just a place we visit but a place we live and work, where humans have established a permanent foothold, testing out technologies that will take us even farther into the stars. The dream of becoming a spacefaring civilization is closer to reality than ever, and the moon will be an integral part of that journey. The future of humanity's relationship with the moon is poised to be transformative. As we continue to explore, learn, and grow, the moon will always be there, a constant companion on our journey into the cosmos. It will challenge us, inspire us, and push us to reach for new heights, just as it has done throughout history. Final thoughts. As we wrap up this exploration of the moon, let us reflect on its impact on our lives and our future. Whether through the lens of mythology, science, or space exploration, the moon represents more than just a celestial body. It is a mirror that reflects our ambitions, our curiosity, and our unyielding desire to reach beyond our earthly bounds. The moon's influence is timeless, and its role in humanity's future is limitless. As we embark on new missions to the moon and beyond, the legacy of past explorers, scientists, and dreamers will continue to guide our path. The future of space exploration is exciting, and the moon will remain a critical milestone in the journey toward a deeper understanding of our universe. Engagement prompt: what are your thoughts on the moon's role in human history and space exploration? Do you think that establishing a permanent human presence on the moon is the first step toward becoming a multiplanetary species? How do you envision the future of lunar exploration in the next few decades? Share your thoughts, and let's continue this conversation as we look toward the stars.